So this is our one-step equations video covering addition and subtraction. There's a second video that's going to cover multiplication and division. You'll get to that one in a little bit. Here's the goal today. We're going to go through some problems. Got a problem here, got a problem up here, got some more problems right over here for you. And after I explain the scale problem, kind of a review, and the first problem without the scale, then what I'm going to suggest you do is, as I bring a fresh problem out, pause the video and try to solve it. After you've tried to solve it, then come back and watch the solution, and then do the next problem, and then do the next problem. When you're all done, if you want some extra practice, come see me, and I will give you the week concept 16.1 practice sheet. It has, I think it's 8 problems on it, and they're all worked out on the back. Remember, your goal is to be as ready as possible for next Tuesday's test. So let's get started. If you remember what we did in class over the last couple days, we took problems like this one on the scale, and we said, all right, we're going to take this 3 and this x, we're going to stick it up there, x plus 3 equals 8. We're going to create some workspace down here. You don't have to be doing this on your paper. You can just watch, just a review. We're going to bring down the parts. So on this side of the scale, we had an x and we had 3 ones. On this side of the scale, we had 8 ones. 7 and 8. Then we asked ourselves, what do we need to do if we want to get x by itself? That's the goal, get x alone. Here's one rule that we set. Everything is addition. Everything, you're getting sleepy. Everything is addition. All right, remind yourself, everything's addition. So we can't subtract. You can't say, oh, I'm going to take away 3. What you can do is you can get rid of it by doing the opposite. Instead of adding 3, you can add negative 3. If you add negative 3, let's go down right here and add 3 negatives, you're going to find that these cancel out, and these cancel out, and these cancel out, and the only thing left is x. Now, you probably already know what x is equal to. You know that it takes 5 plus 3 to get 8. So the good news about a problem this simple is that you don't have to wonder what x is. Once you do the steps, you get to see if you're right. We have to go ahead now, let me write it here, we have to go ahead now and we have to add the negative 3 to the other side. We talked about that in class. As far as something staying balanced, here's the rule. Whatever you do to one side, you have to also do it to the other side. That's the only way things stay balanced. So that was one of our rules. Whatever we do to one side on the scale, we have to do to the other. So since we added 3 negatives on the left, we have to add 3 negatives on the right. So we add negative 3 on this side of the scale. Same 3, 0 pairs. 0 pairs are going to be the same on each side. And what's left right there? What's left are 5 ones. And we get x is equal to 5. We know that's true. We are going to do one more thing, though. We are going to do a check on this. So let's get that out of the way for just a minute. And we're going to do a check on this problem. And the way we check it, write the word check. The way we check it is we go back to the original equation, x plus 3 equals 8, but instead of x, we write 5. We wrote what we just got for an answer. Is 5 plus 3 8? Yes, it is. We did that problem correctly. We can give ourselves a smiley face. So that's your quick review of what we did in class. Now let's look at how we do it without using the scale, because when we get bigger numbers like this, x minus 21 equals 15. Those bigger numbers would be hard to draw. So let's look at how we do it without drawing. Well, our first step is the same as what we did before. Draw that dashed line. That dashed line reminds us that whatever we're doing on one side, we have to do on the other. The next step is go back to what we did here on the scale. We had 3. How do you get rid of 3? You add the opposite. Well, here we've got a subtraction problem. Remember our rule about everything has to be addition? Our first step on this problem is we're going to rewrite it as addition. So our first step is to make this an addition problem. And we did a bunch of these in class. Instead of x minus 21, we're going to have x plus negative 21 equals 15. We didn't change the value. We just rewrote it. Instead of subtracting a positive, we're going to add a negative. So now we're going to go and do the steps. And let's give ourselves just a little more room. Let's collapse that up. Give ourselves a little more space to work right here. Okay. So now we're ready to actually solve it. We have it written as an addition problem. X plus negative 21 equals 15. Just like we did the add the opposite here, we're going to add the opposite here. We're going to add 21. And just like we did it on both sides over there, we're going to do it on both sides over here. On the left side, these create 21 zero pairs. These cancel each other out. The only thing left is x. On the right side, you have 15 plus 21. 15 plus 21 is 36. Our last step is to do a check, is to find out if we put x in the place of the original, 36 minus 21, is that equal to 15? And yes, it is. You could set it up this way. 36 minus 21, 6 minus 1 is 5, 3 minus 2 is 1. There's our 15. Give yourself a smiley face. That was a silly looking grin. Let me go back and fix his smile. There it is. Give yourself a smiley face because you did it right. Okay, now I'm going to bring the next problem out. And what I'd like you to do is pause the video and try to work that problem. We're going to take this one, so you have it to refer to. Just shrink it a little bit so there's some workspace when I do the next one. And now you've got the one with the scale to refer to if you need to. You've got one without the scale. And you're going to try solving this problem. Let's make it a little bit bigger so you can see it. There you go. X plus 18 equals 10. You already probably know what that's going to be. In fact, you're probably saying to yourself, wait a minute, something plus 18 gives me a smaller number? I'll bet that x is a negative. You might be right. Let's find out. So pause the video, go through the steps to solve it, then start the video back up and watch the solution. Okay, here's our solution to this problem. First thing I'm going to do my dash line. I always do the dash line because it reminds me to do the same thing on both sides. Next thing I'm going to do is the opposite of adding 18. Well, the opposite of adding 18 is to add negative 18. So I have to add negative 18 here, and I have to add negative 18 here. On the left side, 18 plus negative 18, that's a great big zero. That's 18 zero pairs. The only thing left over is x. On the right side, I have 10 positives and 18 negatives. If I drew out the 10 positives and I drew out the 18 negatives, I'd end up with 10 zero pairs. The 10 positives would cancel out 10 of the negatives, and I would have negative 8 left over. Because I'm canceling 10 of the negatives, that leaves 8 negatives left. X is equal to negative 8. Let's see if that makes sense. Let's check that problem. Does negative 8 plus positive 18 equal 10? Well, yes, it does. 8 negatives, 18 positives. Those would cancel out. You'd have 8 zero pairs, and you'd have 10 left over. Yay for us. We did it correctly. All right, let's shrink that one down. Leave it to where we can see it. Let's put it, remember our rule here. Same thing to both sides. I'm going to shrink the rule down. Put this right down here. So we're building a whole set of problems that you can refer back to. So you've got all of these now that you can refer to. There are 3 different problems that you can use for reference, plus our rule about do the same things to both sides. Let's bring out our next practice problem. Here we go. And please solve this one. Pause the video, solve the problem. Okay, time for our solution. So, dashed line. Remember to do the same thing to both sides. We're adding 12. The opposite of that is to add negative 12. So I'm going to add negative 12 to both sides. Over here, adding 12 and negative 12 gives me a big old 0, which means only x is left. Over here, 8 negatives plus 12 more negatives is going to be 20 negatives. No 0 pairs. There are no positives to cancel negatives out. Everything's negatives. Let's do the check and see if that makes sense. Well, if you have negative 20 and you add positive 12, does that give you negative 8? And yes, it does. These 12 positives cancel out 12 of the negatives, 12 0 pairs, and that leaves 8 negatives left over. Yay for us. All right, that's another one for us to shrink a little bit. And let's bring out our next problem. Here is the next one to try. Once again, you're going to go ahead, you're going to pause the video, and you're going to try solving this, and then we'll turn the video back on, check your work. Okay, you've had a chance to solve it. You probably know right where this is going. Here is our problem line. That reminds us to do the same thing to both sides. Here we have negative 28. Now this isn't subtracting 28, it's negative 28. How do you get rid of negative 28? You add 28 to it. Because if you have 28 and negative 28, they're opposites. They create 28 0 pairs. If you added 28 to that side, you also have to add 28 to this side. So what's it look like now? Well, negative 28 plus positive 28 is 0, so the only thing left here is x. What's 12 plus 28? Well, 0, carry a 1. We've got 40. Let's see if that checks out. Here's our check. If you have negative 28 and you add positive 40, does that equal 12? You bet it does. Because you have 28 negatives, they're going to cancel 28 of these positives out, and that leaves 12 positives. Another way to think about it is, ask yourself 2 questions. Which do you have more of, positive or negative? Well, you have more positives. The 40 is bigger than the 28. How many more? Well, do the 40, take away the 28. 40 minus 28, there's a 2. We had to borrow. 3 minus 1. There's our 12 again. So the check works. Yay for us. All right, we're going to have one more problem to try. Let's bring it out. Before we bring it out, let's grab a little space here. So once again, we're going to shrink this up. Let's park it right down here. Let's take our space. Now we got a whole bunch of problems to refer to. Yay for us. And we got one more to bring out. Here it comes. X minus 35 is equal to 48. And the process for solving, well, why don't you go through, solve that problem, and then turn the video back on. Okay, time to solve. So you've got the line, so we remember to do the same thing on both sides. This is a problem that violates our rule. Nothing can be subtraction. So we have to rewrite this problem. You probably remembered that, and you rewrote it as x plus negative 35 is equal to 48. If you didn't, if you got stuck, pause the video now and finish out the problem. Okay, let's finish it together. So we're adding negative 35. How do we cancel that? By adding positive 35. There is a giant zero, 35 zero pairs. If we add 35 there, remember our rule says do the same thing to both sides. We have to add 35 on the other side also. X plus 0 gives us x. 48 and 35, well, 8 and 5 is 13, carry a 1. 5 and 3 more, 83. I could probably do a better job on that 8. Let me see. Yeah, a little bit better. All right, 83. Let's check to see if that works. So x is equal to 83, which means where we had x, we're going to put in 83. We're going to take away 35. We're going to see if it's 48. When we do the check, it's okay to do subtraction. We'll do the original problem. We don't have to change it. So 83, take away 35. We have to borrow from the 8. That's a 7. 13. 13 take away 5 is 8. 7 take away 3 is 4. There's our 48. Super yay for us. And we're ready to move away from this video. So you've had a chance to do a bunch of problems. Come see me and I will give you this. It's part of your homework. I'll give you this so you can practice some more of these. All right. In a little bit, after you've done some practice, it's time to do the next video, which is one-step equations, multiplication, and division.